So the static of my topic is write everything only once. Basically, we started when I'm going to work for a government agency, and they had a mainframe application with a cobol generator. I wasn't there to work on that application. I was there for the IT, but I decided to rewrite the thing on my own. So in Smalltalk. Trying to do that would be more or less because of the fact that generate a lot of code. So I basically decided that I wouldn't write a one sentence double. So I took that as a guidance when I started this application. So I have two topics. First of all, a big introduction to the application. Then I'll discuss some of the Smalltalk implementation I did, mainly to illustrate the fact that what I did will not write something in double. Then we'll have this small discussion on the metrics of the different implementations, because in the meantime, the government agency has decided to write things in Java. So we have three different implementations of the same application. And finally, I will talk a bit about how to be successful with Smalltalk. So the RGB application is basically an application where the agency gets the dates and the salary associated. They get also some certificates that basically try to confirm the date and the associated salary. So they are used basically for the checking of, for the cross-checking of the information that's in it. And they also use invested in bank accounts, because sometimes the money is transferred to the worker as a circular check, or it's transferred directly to his bank account. So the basic purpose of the exercise is to pay the vacation allowance to the worker. In Smalltalk implementation, what I did is basically I made two container hierarchies. Basically, every entry, basic entries in the system are identified by year, occupation, investment, the attestment, the versions of the attest. So what I did is I built a container structure which is basically two-directional, because you need to get a lot of navigation to find information. Some information is at most of the information is at higher levels, so you have to pick up, for example, the sex of the worker. It's interesting to know that only at the level of the worker you find the information. And then you have to make a lot of totals on all sorts of levels. As I said, there is a lot of verification to do. So I'll probably show you how I made the container structure. So they're basically all entries are the basic entries and the LRCA container are all part under an LA80 entity. So the basic entry contains all the days that there are, as you can see, there are holiday days, there are salary days, so there's plenty of different days that have to be accounted for. On the other hand, we have then the container hierarchy, which basically contains things like year, trimester, occupation. And as I said, the structure is built dynamically, which basically means that I'll show you a few examples of that. Whenever you add an entry, like for example, the worker has an entry, so we basically have the entry to the activities for the worker. So it's all passed through from one to the other. The entry is implemented in added. Creates the year if necessary, and then that's the entry to the year. And then it goes on to the trimester. As you can see, it's all single line codes, nothing gets duplicated in this here. Oh yeah, navigation, that's so for example, you see the implementations for everything, for example, is 6 self-contained 6, so it's get past the hierarchy, so whenever you have to find 6, you let it go. If you get this level, you go up to the Oracle level to find everybody wants to take 6 picture. So for the verification, basically I used a delegation pattern that I squared it. So basically every LLD implements exceptions with basic this return exceptional self. And then the exception finder, which is the delegation which has been delegated, takes all the possible exceptions which it finds in the target. So every entity has to define the exception is supposed to be checked. So you see here the entity class. One of those is this one, which basically says you have 3 exceptions here, I have to check. And then we basically we find all the possible exceptions. So as you can see with this type of coding, you find for every bottom line or for every entry line, you find all possible exceptions. You just have to indicate the name of the exception, and whenever it's necessary, it's automatically checked. The code for the exceptions itself is you can see most of these contain then target content of a test. So you basically have one line of code. So because of the different exceptions, several exceptions are valid for certain entries, you only have to code the exception once. For the totals, we have introduced a concept called carrier total, which collects totals over the container structure. So both container and each subclass of basic entry implements the carrier total method, which in the container part is just a question of passing the carrier total down the chain. The carrier total itself, all of the bottom line entries have to implement a subset of what I've given here as a complete line. So it picks up the lines of code it needs on this entry. So in the calculation we use an error-free carrier total, which basically is a combination of both. I told you how it's easy to find exceptions. Now with this solution you can find all error-free entries and then make the carrier total on all error-free entries. The advantage of this solution is that you can make totals on all levels and it's all using the same code. But I found out this when I implemented this thing that I was using a lot of unit testing, and in the calculations, it became very clear that performance was getting a problem. So what I did is, as you can see, it uses here late initialization, and on top of that, I will reset. So whenever I add a new line of a new entry to one of the containers, I basically reset the carrier total. So it's easy to then the link is reinitialized again. So what's the advantage of this implementation? All duplicate code gets eliminated. It's simple to navigate, and without the basic thing is that, as in every government, they also make new rules. They find new days and they find new exceptions. With this implementation, to implement a new day, implementing a new day is just a few lines of code. So I also use the command pattern. Normally it's used only for undo and redo. I also use it for access control. So by creating access control, I basically get a user profile. Every user profile is combined with a number of service profiles. And in the service profile, I put all the commands that are supported for a certain user. And you have some special users like system and find, and you basically take all commands, or find, which takes only the commands that are necessary to find something in the system. So, for example, I have a system which basically takes all commands, all subclasses of commands, and selects the one which are valid. And for example, worker, which is basically the guy himself, when he wants to look at his data, he basically gets all find commands, but also the address command, because he's allowed to have his own, he changes his own address in the system. For database import, I use object extender, which is not valid or not available anymore, or not supported anymore. And I have done some work lately to port it to Word, but I haven't finished that one yet. Now to the metrics. The cobol generator application, which was the original application, which was written for the RUV, took 29 years. And for the moment, they are still using a maintenance team of 10 people to maintain the application. Smalltalk implementation, well, I talked a bit about it. It has 352 classes, but most of those classes are automate classes that are basic entities, so the total is much less than that. I basically spent probably 2 years over a 5-year period to write it. And it contains more functionality because people who were doing the cobol generation, they never managed to finish the application completely because it was too complicated. The Java application started in 2008. They got a budget of 8 million euros, and they never finished the application. They started in 2008. It was supposed to be operational years already. They basically, the last one I heard is that it should go in operation this year. But that they have said last year too, so I don't know. The Smalltalk implementation before it had been operational, it was shown to perform. It got a positive technical review, but it was never put in production because the professor of economy came around and told that the thing should be written in Java. So that's a very curious story. So what I found when I looked at this code, and I been working in the Danish government for a few more years, changed agency, for what reason I don't know. But I found out that a lot of applications in government have much more the same structure as what I did in the programming for the RUV. So probably most of the code I did for RUV can be used for a lot of government applications. So my suggestion is that if somebody wants to make a lot of money, he should go and bid for some government application. Because with Smalltalk we can offer a solution for a fraction of the cost. And if you offer it to educate the local staff to do the support of your application, they'll probably be more than honored to do that. Maybe to conclude, I just found out that the Ministry of Finance in Belgium is going to pay 10 million euros to make, in total I think 30 million euros to maintain their Java application, which is more or less not only front-ending to their still existing cobol mainframe application they can't replace. So thank you for letting me share this story.